Hello and welcome to a chapter on network segmentation and virtualization. So in today's chapter, we're going to be discussing um, subnetting, especially the VLSM, the variable length subnet masking, or sometimes it's referred to as the CIDR, the classless interdomain routing, and supernetting. Then we'll get into, and we'll talk about both, by the way, IPv4 and IPv6. And then we'll discuss the importance of virtualizations and how it works. And we'll discuss some techniques for incorporating virtual VLANs and what is a VLAN and how does that work. All right, so segmentation and subnetting. Segmentation means dividing the network into multiple smaller network. So please write that down because one of the first things that you want to do is when you get into, if a client calls you up and he says, we have 5 or 6 departments, you want to break up the whole network into smaller segments, smaller subnets, subnetworks. The smaller the network, I want you to write this down because that's why we do subnetting. So the benefits of subnettings are better security, better performance, and easier to manage. Okay, so because just imagine you are within, and because it's a broadcast domain, a local area network, a subnet is its own broadcast domain. If someone broadcasts in the LAN, only the people inside that LAN will hear it. So if you have 200-300 people in the LAN, no one will be able to communicate if someone is broadcasting. So you want to, and you have to broadcast, by the way, every time you want to communicate with anything inside your LAN. Let's say you want to print. Remember, you have to do the ARP request, and that's a broadcast message. So when somebody does an ARP request in a LAN, everyone in the LAN will not be able to communicate or even get on the router. So imagine if they have a large LAN, so it's going to take more time for the performance drops because it's less likely that you will be able to get to your resource as quickly as possible. So traffic on one network is separated from another for security purposes, and each network has its own broadcast domain. So from now on, if someone asks you, what is the technical definition of a local area network, a subnet, and it is a broadcast domain. All right, so moving on. All right, now we're going to get into subnetting. So let me just, since you wrote that down, I also wrote a couple of notes that I want you to take a look at. So let's take a look at subnetting. All right, if you remember, the IP address contains a network address and a host portion, if you remember that from a couple of chapters ago. And when you have a network such as this is, if you remember, this is a Class C address because it starts with 192. And Class C says that the first 3 addresses, the first 3 bytes are the network address and the last byte is the host. So Class C means the first 24 bits is your network address. So when you have a number, when you have a /27, so it's no longer the first 24 bits are your network address. It's the first 27 bits. That's what this /27 means. So if somebody gives you an IP address such as this, 192.168.10.170/27, and says, what network is this person belongs to? First of all, this /27 is the really subnet mask address. And the way you write it is this way, in binary. /27 means there are 727 ones in the subnet address, and then the rest are zeros. Because the whole thing has to be 32, the rest is 5 zeros. So how do you rewrite this? 8 ones is 255, another 8 ones is 255, another 8 ones is 255, 3 ones and 5 zeros is 224, because it's 192 plus 64 plus 32, right? Remember that? So /27 in / format means 255.255.255.224. So what a router does, which we will discuss in another class, to find out what network the address is in, is it takes this address and places the mask, the subnet mask address, this underneath it, and does what's called a logical AND to find what the network address is. All right, but we'll do that, the logical AND, in another class. For now, what you could do, a quick way of doing this, if someone asks you what is the network address of this, so what you need to do is, well, you know that the first 27 bits is your network address. So write this number, all of this 32 bits in binary, and you know that the first 27 bits is your network address. So here's 192.168.10.170 in binary. I wrote, here's 192 up to here, 168 up to here, sorry, and what did I do here? Oh, I'm sorry. 192, 168, 10, and from here to here is 170. I just separated them. You see, there from here to here is 27 bits, and this is your host. Now, here's another thing I want you to realize. Remember, this is a class C. This is a subnet. These 3 bits, these 3 additional bits out of the 24, you have 24 bits, and there's a 3 additional bits from class C we took to create subnets. So this is subnet 101 is subnet 5, right? 110 would be subnet 6. So if you took 3 bits, you could have, broken this into 8 subnets, because in 3 bits you can do 000, 001, 010, and so on. All right, so this host 01010 is in subnet 5 in the original network of 192.168.10. You understand? So the way you would write the network address is you would write the first 27 bits. If someone asked you, what is the network address? That means they don't care about the host. So what you do is you write down the first 27 bits, just like I did up here, but instead of writing the host, you make them all zeros. Then you rewrite everything, 192, 168, the 10, but 101 with 5 zeros become 160. So this address, network address, is 192.168.160/27. Is that clear? So the steps are: you write down the first, you write down what the slash says, the first 27 bits in this case, and then the rest you make them zeros, and you rewrite everything in decimal format. All right, so here's another example. By the way, I want you to write all of this, of course, right? All right. So in addition to that other thing that I told you to write just previously, here's another example: 172.16.230.92/20. This is class B, right? Just to remind you. So /20 says, by the way, if someone says, what is the subnet mask address? You write 21s and 12 zeros, right, to make it 32. So this is the mask written in format. So this is /20. Okay. So if someone asks you what is the network address up here, so all you need to do is write the first 20 bits, and then the last 12 bits, just make them zeros, right? So here's 172.16.32.92, right? So here's the first 20 bits up to here, right? And these are the last bits. So because this is this is a class B, this would be the subnet, right? The 4 bits in addition to the 16 would be, this is what subnet, and this would be the host, right? But to write the network address, it's always the class B address plus the subnet, and the host, you make it 0 if you want to name the network address. So this would be the network address. it is 172.16, and 3 ones and 5 zeros is 224, and the last 8 bits are zeros. So this is the network address of 172.16.32.92/20. All right, that's okay. This is good enough for now. So it's, if someone asks you what's, you know, give me the IP address of this slash, and so on. Supernetting, meaning go inside. If this was a class B, you actually went inside here. Excuse me, into borrowed numbers, not only from the host. So you went in and actually you had a not /20. If you have something, you know that this is a class B, but the slash that you see up here is something less than 16. If it's slash less than 16, that means you went into the network address and took some of the network, the original class B address bits, and borrowed bits from there, right? So anything that you see less than class B, it would have been Supernetting. So if you have something less than 24 for class C, less than 24, it's Supernetting. Less than 8 bits, less than /8 for class A, it would be Supernetting as well. Anything larger than that, then it's not. All right, for IPv6 subnetting, there is really no subnetting, to be honest with you. Why? Because if you remember when we took the IPv6 address, the first 3 numbers in an IPv6 address indicate the registry that you are in, the regional internet registry, the RIRR, which part of the world you are in, who's your ISP, and who's your company, the site. That's the first 3 hex stats. Remember, each one of those is called a hex stat, and it's a 16-bit number. So each digit in here, because it's a hexadecimal number, is 4 bits, right? This 4th hex stat, which is 16 bits, is the subnet, always. So there's really no subnetting needed. So for this network, so if any company have this address, this company has 16 bits to create subnets, which means 2 to the 16 is, you know, over 16,000 subnets you can create with one IP address. That's why I say there's really no subnetting needed, right? So the 4th hex stat is always the subnet. So therefore 00A, because this is A in hex, is really 10th. So this is the 10th subnet. Remember, there's a 0 subnet, 1, 2, 3, all the way to F, and then it will becomes 1, 0, 1, 1, all the way to FF, and then you increment, okay? Remember, the last 64 bits is the network ID number, all right, which is like the host. All right, you could, by the way, I don't know, I don't see this though in the foreseeable future, that you can actually get into you could do subnetting, don't get me wrong. I mean, if you need more than 16 bits to create subnets, you know, more than 16,000 subnets, you can actually dig into the host portion of the IP and borrow bits. But I don't see anybody really doing that. So as far as I'm concerned, and probably you never have to worry about subnetting in IPv6, but they left that door open if you ever need it, which I very, very doubt. No one is going to manage over 16,000 subnets with one IPv6 address when there is an abundance amount of IP addresses available. All right, so that's that with subnetting in IPv4 and IPv6. When we get into our Cisco classes, we're going to get into details with the subnetting. So we'll practice almost every day, so you'll be an expert in that. So for now, we'll just leave it at that. All right, so that's that. So we can go beyond this. So you remember the classes ABC. Here's the typical address we talked about. The first 24. All right, we talked about that. Why we subnet, we talked about that. Here are 4. By the way, each subnet is its own LAN. and each LAN has to be connected to its own switch. So each switch with all the devices connected to it should have its own subnet address, because a switch is its own broadcast domain, right? So you have 3 subnets here. Okay. The mask that is used is really when you're given an IP address, the router, if the router will take the mask and will mask the host portion of the IP so it knows which network, what the network address is. Okay, that's what the subnet mask address, that's what that slash number mean, really. All right, so here is the subnet mask. Remember /17, you have 17 ones and then the rest are zeros, right? So for /17, this is for class B, 16 bits, right? So you're using only 1 bit. You're borrowing 1 bit after the 16. With 1 bit, you can create 2 subnets only, right? Subnet 0 and subnet 1. If you borrow 2 bits right here, a /18, because remember class B has 16 bits, so you borrow 2 more bits, you can create 4 subnets, right? You can borrow 0, 0, 0, 1, 1, 0, 1, 1. If you did /19, that means you borrowed 3 bits, right? That means you can create 8 subnets, right? 2 to the third. 4 bits, 16, and so on, right? If you borrowed 1 bit, that means you have 2, what is this? 15 bits left over. 2 to the 15 gives you 32,766. 14 bits left over. This is how many hosts for each subnets you'll have, and so on. For class C is the most common, by the way, right? Borrowed 1 bit to host, but you have 7 bits left over. 2 to the 7 is 128. You got to subtract the 2. As you get 126. Why do you have to subtract the 2? Because all zeros cannot be assigned to a host. All zeros and all ones is a broadcast address. But we'll discuss that in a different class, actually, not in this class. This is an intro class. So what you need to know for now is good enough. We'll continue with some of it. So for here's an example. 192.168.89.1/27. These are 3 different subnets. You see the first 3 bits, I can see the first 3 bits are zeros here. The bar is 0. This is in subnet 0. I know the first 3 bits, because this is a class C, this is in subnet 010. This is subnet 2. And 64, actually, I'm sorry, this is in subnet 1. This is in subnet 2. Subnet 0, 1, 2, right? Because the first 24 bits you cannot touch. And if you write 32 in binary, it's 0, 1, all zeros. You need 3 bits. 0, 1, 0 is 2. That's how I come up with 2. All right. I'm sorry. 32 is 0, 0, 1. The 64 is 0, 1, all 0. That's 2. This is subnet 2. This is subnet 1. All right. So this is how you would break up the network. By the way, if you see a router and someone asks you how many subnets do you have, you just count the interfaces on the router. Each interface on the router is its own broadcast domain. Please write that down. Each interface on the router is its own broadcast domain. Put in parentheses also LAN, because a broadcast domain is a LAN, or comma subnet, also a LAN, right? Okay, Supernetting, like I said, combines the networks. If you have anything smaller than, for class A, any number, the slash number is less than 8, then you know we did some Supernetting. We don't really bother with this as much, although it reduces the number of routing entries in the routing table, and it's really not used, to be honest with you. I don't even bother with this. Everybody uses 192.168, and it actually creates a lot more. You can, if you wanted a lot more subnets. This was helpful in the late 1980s, early 1990s. So this is legacy stuff, but you never know. They may ask you. All right. So that's that. Okay, subnetting with IPv6. Like I said, it's really not needed. So all you have to know is so this subnet is subnet 1. You see that right here. Actually, I'm sorry. Yeah. No, first, okay, this is subnet A, right? The 10th subnet, because the first 3 hexnet is not. And this is the network ID, right? The first 32 bits are really not, it's the name of the network. The 4th hexnet is your subnet. It's already reserved, so you can 16 bits for you to write down your subnets. Okay, so the first is the registry, the regional ISP. Actually, the RA, the regional ISP, and actually the site, and this is the subnet. Okay. All right, so let's get into virtualization. What is virtualization? Please write this down. Is the emulation of a computer operating system environment or an application. Actually, you can not only that, you can run servers, you can have a whole network by yourselves. But you will have, and we'll practice some of this in class. We can run Oracle VirtualBox on Windows 10, and the Oracle VirtualBox will act as a hypervisor, we call it, and you can install different operating system within the VirtualBox. You can install Apple iOS, Unix, Linux, you name it. What other Windows servers within, and the base host, the host computer is our Windows 10. So you can have, what's the advantages of that? Of course, you don't have to have a physical machine dedicated to each one of those operating systems or servers, right? So you save a lot of money, of course. But the disadvantage is if this host crashes, you have a central point of failure. That's a big issue, right? So you can configure virtual devices. Each virtual machine can have its own memory, how much of the host CPU it can use, how much of the hard drive it can use. And by the way, it's virtually. If you turn it off, you're not using the hard drive or anything like that. But when you turn it back on, it remembers all the data. So if you're planning on to creating a virtualization environment for your organization, the host have to have a very large amount of hard drive space and lots of memory and lots of CPU power, right? Because you don't want, because otherwise, if you're planning on putting a lot of servers and operating system in the virtual environment, you're going to slow things down if the host system is not updated. All right, so that's that. So the hypervisor is, write this down, a software that allows you to define and manage the virtual machines, also known the virtual machine manager. So this is graphical illustrations. So you have your physical NIC in here. You can have 2 separate operating system, and the hypervisor is like the virtual box that connects these with everyone else, allows you to communicate. They can talk to each other without going outside. They can use your NIC to get outside on the internet if you wanted to, or they can just sit there by themselves and do nothing. So we'll talk about that in a few minutes. All right, so I want you to write down the advantages and disadvantages of virtualization. Of course, the advantages is the efficient use of all the resources, cost and energy saving, right? Fault and threat isolation, and simple backups and recovery and replications. The good thing is if something fails, in any of these servers in the virtual environment, you just turn it off. It's just like an app. If there's a virus that got in, get rid of it, then you can reinstall it. Much easier that way. The disadvantages is you compromise performance, but if your host has enough memory and hard drive space and very fast CPU, maybe quad CPUs or E8 or whatever you can afford, then performance, will be acceptable. Um, Single point of failure is probably the biggest issue because if for whatever reason the actual host crashes, then you'll lose connections to all these virtual and servers that's on there. VMware is the most widely deployed. It's stable. They cost you a little bit of money, but it's the most widely deployed virtualization. Cloud computing love to use it. It's much easier and it's all software because you can communicate with your servers remotely through the virtual environment. You can actually create your own virtual environment. You don't have to go to the cloud. So you can have a host and you can run all applications, operating systems all over, and you just tell your hosts, somebody that has remote access, he could be having Windows 10 instead of installing any applications on their system. And you just tell them, all right, you give them a connection. They come into the virtual environment remotely and they can access any if they want to run a different operating system, any applications, they'll have access to it. So they don't have to carry many. So their machine could be just running Windows 10, and as long as he connects to the internet, he has enough memory, he'll be able to connect to the virtual environment. You don't have to worry about installing any applications on their system, upgrading, or none of that stuff. You just need, and you only have one big host machine that you have to take care of. That's what it really comes down to. All right. Microsoft has VMware is by the company VMware. Microsoft Hyper-V has their own. Oracle is free. I'm sorry. Oops. It's free of use, so you can do that if you wanted to. Okay. There is the Citrix Zen app. That's also deployed a lot. I've used that as well. It's really, to be honest with you, that's where everything's going. Everybody wants to go to the cloud. It gives the company a lot less headache. And to go into the cloud is made up of virtual machines, believe it or not, much easier and easy to administer. You as an organization, you just pay a little fee and you can connect and being able to connect and having access to your resources whenever you want to for a little fee. And those fees that you're paying, you don't have to worry about administering all the servers locally, backing them up, securing them, none of that. And you probably don't need any personnel either. You just connect to the cloud, get whatever you want to. They take care of everything for you, right? And you just pay that little fee. They make a lot of money because really all they're doing is their service. They're not really doing anything. Once they install the applications, you don't have to worry about licensing, none of that stuff. That I'm telling you, that's where everything is going. Microsoft is pushing their Azure, Amazon Web Services. That's where their biggest money maker, believe it or not the Prime, whatever that they're doing, although they're probably making a lot of money on that as well. But I'm telling you, the Amazon Web Services, that's where their biggest margin of profit is. Those are the biggest two companies. Amazon Web Services and Microsoft Azure is the biggest web service. But there's plenty of competition. Salesforce is out there playing it, VMware, IBM's trying to get in there as well. Oracle, everybody wants a little piece of the pie. But we'll see we'll see where everything goes. All right, you can have your own virtual network internally if you want. Now you can set up your NIC in each virtual machine operating system. You can have your own virtual NIC. So for example, let me just go through this for a second. You can have your own virtual switch in there. So let's say you have a Windows 7, just to make it for simplicity, a Windows 7 and a Windows 8 and a Windows Server, three different machines connected on those are virtual machines, and the host is Windows 10. So again, 7, 8, and a server are in a virtual environment on a host inside a virtual box, let's say, and that virtual box you installed it on Windows 10. So Windows 10 is the host. So let's say here are the three. You got Windows 7, Windows 8, and you got the server. The host machine is Windows 10. And this is, you created a virtual box. So all these three guys are connected. These three guys can be connected to the outside world too, using, you can have two NICs if you want, or you can have just one NIC. If you only have one NIC, you can use it to get on the internet. These three guys can use the physical NIC to get on the internet, but it's probably, preferable that you have two NICs. One NIC is dedicated to the host, and the other NIC will be for all the virtual machines. You could have two hosts connect to two NICs, connect to a router. I mean, you can set it up like way through a bridge. Now, typically they're connected in three different ways. So I want you to know the difference, and I'll show you that when we do that, when we can set that up when we set up a virtual box, so we can do that really quick. Bridged environment, NAT environment, and a host environment. In a bridge mode, so write this down, the virtual NIC accesses the physical network using the host machine's NIC. So, and they get IP addresses also, gets its IP address and the default gateway and the mask from the DHCP server, from the physical NIC. So like this, if you set it up as a bridged network, so that means they go outside and they get IP addresses from the outside DHCP, and they have their own IP address as just a regular device that is out here. They act as a physical device as out here, and they can get on the internet just like any other device. So instead of having a Windows 7 and a Windows 8 and a server out here, three different machines connecting to the internet, they are in here and they can connect to the internet as if they are three physical machines outside. That's a bridge network. And this is done automatically, by the way. Okay, so you just, when you get in here, for this machine, you just choose the NIC as a bridged, and they'll be able to go outside and get their own IP address automatically. If you choose this as a bridge, they can go outside and get their IP address automatically, and you don't have to worry about anything else. All right, if you set them up as a NAT, so write this down, a VNIC relies on the host to act as a NAT device. So they obtain an IP address information from the host, and the virtualization software acts as a DHCP server. So this happens internally. So you can have an internally DHCP server, such as this in here. He'll give them the IP addresses. So they have their own network environment, like a virtual LAN. You could do that if you, so for example, if you wanted to practice server 2012 or 2016. So let's say this is the server 2012 and this is Windows 7. So he can go in, get an IP address from the server, and he can ping the server, ping other devices inside here to practice, right? So that's the NAT, right? So you can set this as a NAT, set this as a NAT. If you don't want them to go out, but you want the devices in the virtual environment to communicate with each other. So I want you to write that down. And I also want you to write down, if you chose the NIC as a host only mode, that means they're not going to communicate with anyone. They'll just be alone, right? All right, so that's that. The most popular functions of a virtual appliance and a virtual network is you can set them up to be firewalls, network management, for emails, remote access, which is mostly used in the cloud, right? All right, the VRRP, the Virtual Router Redundancy Protocol, and the Hot Standby Routing Protocol. Uh, the VRRP, and specifically the HSRP, is the Cisco proprietary version of HSRP, which, by the way, we will do in one of our Cisco classes. We will set up a hot standby routing protocol. So what that means is you'll have two routers. One will be on standby and the other one will be active. The active one is the default gateway for all the users to get on the internet. And the idea is the active one, if it fails, all the hosts will automatically, without you doing anything, will reroute themselves, and the standby becomes the active, and that standby will take over to connect you to the internet. So you're creating some redundancy here, and a redundant default gateway, right? Redundant router. But that router will just sit there and not do nothing until the other, if anything fails on the router, you are rerouted automatically. And we will do this, and you'll see it. We will do this in a lab environment, but that will be done in one of our Cisco classes. We cannot do this in this class because you don't have enough background information to really configure and design the HSRP. All right, so just write this down. The HSRP is used to create a redundant default gateway where one router will be the active and the other one will be a standby. By the way, another thing that is going big is the SDN, the software defined networking. So please just write this down. It's the virtualization of network services. A network controller manages these services instead of services being directly managed by hardware devices. So what this means is you can actually have your own network in the cloud. So instead of, let's say our class, we are networked together, we can talk to each other, we can get into a printer, we can have our own server. So what we could do that, we don't have to be physically in the classroom to do that. Now we can do, everybody could be home and we can log in. And when we log into a specific, to the cloud, it's as if we are in one network. We'll be sharing our resources. We'll be able to communicate with each other. It's our own broadcast domain, but it's software. We don't have to be physically connected to anything, right? You could do that from home by just logging in to the network. You'll be in a specific broadcast domain, a specific network, right? And they offer you the switching, the security, if you needed servers in that network. It's as if you are physically on campus. So that's great, the SDN, right? And they can be controlled by a network controller. All right, so what is a virtual LAN? A group of ports on a switch so that some of the local traffic on the switch is forced to go through a router. I don't like this definition. So first of all, what is a physical LAN? A physical LAN is, write this down, a physical LAN is when you are physically connected to a switch, because the switch, layer 2 switch, the ports on the switch, when you send a frame to a port on the switch, that port on the switch will broadcast that frame to all the ports on the switch. So if you have a switch with 24 ports and everybody's connected to these 24 ports, you are connected to the physical LAN. A virtual LAN is when you take those 24 ports and you say software-wise, you can get into the switch and you say, all right, I'm going to split the switch into two logical switches. So having two 12-port switches, but you still have the physical switch, right? So software-wise, you create VLAN 1 and VLAN 2. So you have switch 1, switch 2. That's what it means. A VLAN is like a switch. but you don't have to physically buy another switch, right? You just take the physical switch and divide it into 2 or 3 or 4. So let's say, for example, you bought a 24 port switch. Your client says we have we have 4 faculty members, 15 students, and 2 administrators. Each one of those groups have to be in a LAN. So you'll create a VLAN, a switch with 2 ports. So you take 2 ports out of the 24 and you put them for the administrators. If you have 4 faculty, you create another VLAN. You call it VLAN 2 or VLAN 10, and you give it a name. So switch number 2 is switch number 10, and you take 4 ports out of the 24. Well, actually, if you took 2 already, that means you're left with 22. You take 4, you're left with 18, right? And then you create for the professors. And if you have 15, then you create another VLAN and take 15 and put them in for the students, right? Then you have 3 ports left. You'll usually VLAN 1 usually is what you start out with, all 24 ports. You never really do anything with VLAN 1. You just create a whole bunch. And by the way, if you want to expand more ports, you can take more ports and put them, for example, if you have an additional faculty member, just take one of the ports that are left over and you just expand the ports. They're virtual because they are they are not dedicated to a physical switch. You can have more ports, less ports, right? More efficient. That's what really a VLAN is. So what I want you to write down, a VLAN is a logical switch on a physical switch. I hope that makes sense. If you still have any questions, ask me. In class, I will show you that. And we can actually do this. I can show you how to do this. But again, in our Cisco classes is where we do all the configuration. If you want to see it, we'll do it as a class activity. Just remind me in class and we'll do it together. When you have 2 switches together, connected together through a trunk, through a cable, and you have multiple VLANs on one switch and multiple VLANs, the same VLANs on the other switch, and they need to talk to each other. So when VLAN 10 wants to send data to VLAN 10 on another switch and they need to travel on the trunk, they have to be tagged. Every frame that travels on the trunk, they need to identify themselves which VLAN they're going to, and the trunk will tag them according to the 802.1q standard. So the 802.1q standard specifies what frame the tagging, the way you should tag a frame to identify what VLAN you belong to. Okay, that's what it really means. So I don't know this. I don't even think the IEEE standard specifies how VLAN information appear in the frame and how switches interpreted. Okay, this is really vague, but I'm telling you, and then we'll do this also in class. The 802.1q is the standard on how to tag a frame so it can travel on the trunk. So when you get to the other trunk, they see the tag and they know which VLAN you are going to, and they send you to that appropriate VLAN. All right, remember each VLAN should be its own subnet. So you do the subnetting, and that whole subnet will have its own VLAN. Again, I keep saying, in our Cisco classes, but in our Cisco classes, we'll do the design. We'll do the subnetting. We'll create the VLAN. We'll configure the host. Check for connectivity. Make sure everything's good, and then we'll be good to go. Then you can install your software, create virtualization, redundancy, you name it, the whole 9 yards. All right, so this switch can have 2 switches, 2 VLANs, in other words. So this switch will have also 2 VLANs. Instead of buying 4 switches, you have 2 switches with 4 VLANs, 2 here and 2 here. All right, so why do you want to use VLANs? Number one is, of course, just the same idea why we did subnetting. The same exact advantages is because you want to have security, better performance, and easier to manage, right? If you don't want to bother with VLANs, you're going to have a lot of switches, physical switches, because each department has to have its own local area network. So you have to purchase a switch for each one of them. Nobody's going to do that. So what they do is they buy one big switch with a lot of ports and then just manage it by creating VNet because, it's more flexible. You can add ports and remove ports all logically, right? That's really the idea behind VLANs. A trunk is the connection between two switches where all the VLANs, when they want to send data to another switch, they go on the trunk. So the trunk is, so write this down, a single physical connection between switches through which many logical VLANs can transmit and receive data. And remember, when you are traveling on the trunk, those frames have to be tagged according to the 802.1q standards. A port on the switch can be configured as access port or a trunk port. Access port means that it's going to be connected to a single node, which means a whole. Access means it's going to be a data port. That means that port you're going to connect a workstation to it. You're going to be sending frames. That means the switch has to create what we call a MAC address table. If it's a trunk port, that means that port is connected to another switch, not to a workstation. So please write these two down. The difference between an access port and a trunk port. Again, an access port, you're assuming that a workstation will be connected to that port. A trunk port, you're assuming another switch will be connected to that port through a trunk. So this is a trunk. So these ports are trunk ports, right? And these ports are access ports because you're connecting hosts to them. The Cisco VTP, the virtual trunking protocol, this is allow switches to communicate with each other and send VLAN databases to each other without the intervention of the user. That's what it really does. Again, we'll discuss these in Cisco. We'll leave that for later on. What else do you need? VLAN hopping attack. This is one problem that can occur. But again, we'll discuss, this is for more security. Somebody can can go on the trunk and, change the tagging so that he double tags. So when he enters the other switch, the tag is removed, but still he has the other tag and he'll be able to get into from one VLAN to another where they're not supposed to be. But we can actually control that, one of our, prevent that VLAN hopping. All right. If you have that trunk that connects between the switches, what happens if that trunk fails? We got a problem. You won't be able to connect to the other switch. So what we need is another link sitting idle for redundancy purposes. But the problem, if you just go ahead and connect another link, you're going to have a problem because it's a layer 2 switch, and what you're going to end up with is broadcast storms, which means if you have two trunks connected together, everybody will fail. Nobody will be able to communicate with each other because they start broadcasting like crazy. So therefore, you need to run a software called the STP, the Spanning Tree Protocol. So here's what I want you to know. I want you to write this down. STP is used to allow redundant links between layer 2 switches and at the same time preventing broadcast storms and or failures. And by doing that, it's going to allow only one link to operate, and the other link or links will stay idle. And if the primary link between the two switches that is active fails, STP will automatically enable the other link to be active. That's what the STP for. And that standard is under the 802.1d. It prevents loops. That means the frames can go back and forth or broadcast storms. There is the bridge protocol data unit guard that can allow us to help us enforce STP path rules. But again, we'll discuss that at the Cisco classes. This is, I think, is a little bit beyond the scope of this course. So we can just, and how does STP, for example, there's multiple links. There's only, see, these X's means what they do is these will not be used to pass data. They'll just be sitting there, sitting idle as backups. If, for example, this link breaks, so these two guys to be able to communicate with each other, this has to be enabled, and they'll go through this switch to go through here, right? Designated port means port that will be able to pass data. Non-designated port, like this one, will be blocking data. So the one that doesn't have anything means non-designated. Root port, this is because everybody has to send data to the root port. But again, I don't want to get into this. Again, this is beyond the scope of this really course, but I just want you to know that's what the STP does. We'll just make sure that you can reach every other location and all other links that are not good, that just be all the other links that are not used will just sit idle and just be there just in case something goes wrong. All right, and there are different types. There's the rapid spanning tree protocol. This is for Cisco proprietary. The multiple spanning tree protocol. This is an open source. They really kind of do the same thing. There's the RSTP plus and so on. There is the transparent interconnection, lots of links designed to replace STP. This is something new. So it has not been implemented as much. There is the short path bridging, descendant of STP that operates at layer 3. This is for really layer 3 because there's a lot of layer 3 switches out there. We don't do as much of that. It all depends. If you have a lot of layer 3 switches, you probably want to use the short path bridging, something similar to OSPF. All right, switch configurations. You can if you just buy, the least expensive switches, they are unmanaged. That means there's no software in them. You don't get in there to configure them. You're just in there to separate to separate collision domains for faster connection. You just connect them. You cannot create VLANs on them. You cannot remotely access them to do any configuration. All right, so those are the cheap ones. They replace the hubs, really. The managed switch is the one that you are able to get in there and configure them, create VLANs, you can create security. This is what we're going to be working with, and this is what we have. Now, classes, we'll be working with these in this class. We'll be able to see, we'll extensively get into them and manage them when we're doing our Cisco classes, when we design our LANs in there. All right, to be able to get into a managed switch, you're going to go through the console, the management console port to get in there. You could do the AAA method, the authentication, authorization, and accounting method to access the switch, to configure it. You can set port security. You can set the speed and duplex. This is all on the managed switch. Okay, a wireless VLAN. So a wireless controller or a wireless provides a central management console for all the APs in the network. So please write this down. What is a wireless controller? So like I told you, I think in our wireless chapter, when you have multiple access points that are interconnected together, it's best to have a wireless controller in there that controls all of them and manage them. Who's given IP addresses, what is the band frequencies that are in there, what channels and so on. So it'll all be managed by one controller. By the way, they are easy to do, and once you do everything on the controller communicates that information or that configuration to all the attached APs. Okay, there's the lightweight access point protocol, the LWAP, direct wireless frames to the controller by adding extra headers. Okay, that's good to know. Not really need to know, to be honest with you. All right, troubleshooting VM and VLANs. Virtual networks resemble physical networks in many ways. You need to back up, troubleshoot, software updates. If you have the virtual machine itself, if you are the host of the cloud where you have the virtualization, you still have to update all the virtual machines that are in there. If you have a server, you have to back them up. Got to do all the work. So if your organization decide that they want their own cloud and virtualization environment, you're going to do all the work yourself. So there's still going to be backup and licensing. All of that has to be in there. So that's still out there. So you can't get away with that, you know. But again, it still reduces the amount of work that you have to do and the amount of employees. If you have a big company, it's preferable that you do your own virtualization. I know CUNY, the City University of New York, has their own virtual cloud, and uh, and they have all the software that is needed. So any student in any of the colleges in New York, in the City University, need to access a specific software. They go through the Cisco, not Cisco, the Citrix environment, and they'll be able to access their specific application whenever they need it. They just have to have a username and a username and a password. They get in there, they tap into the Citrix icon on their desktop. Once they log in, they choose which program they want to choose. They click on it. If that program requires Windows 7, Windows 7 will load up and then the application will load up. You do your work on that application and you save your information on your physical or on your USB drive and you're good to go. You don't have to install it on your machine. You don't have to go to campus to do the work. You could do it from home in any application that you want. So it's great. Virtualization is the future, but it has to be secured, of course. All right, so that's that for this chapter. All right, please take all the notes that I told you to take, and we will meet again in another chapter. I'll see you then.